Welcome back, students. Today we are going to study a very important topic called chemical bonding. Chemical bonding should be understood by every Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Pluto, always moving around the sun. Have you wondered why these planets do not collapse into the sun, but rather move around it? Let us consider the planet Earth. Have you wondered why a man will lose their stability and collapse into the sun? There will be no desire for or attraction between a man and a woman. Neither will fruits always fall to the ground. Similarly, all substances in our universe, like water for instance, are made up of tiny particles called atoms, molecules, and ions that always attract each other. Our DNA, the source code of life, also contains several molecules attracting each other, implying that the very basis of life is built on the force of attraction between billions and trillions of atoms, molecules, and ions found within and around us. The attraction or force of attraction that occur between these individual atoms, molecules, and ions is what we call chemical bonding. In short, chemical bonding may be defined as any force of attraction between atoms, molecules, or ions. In chemical bonding, we have two main types. We have two main types of chemical bonding. One between atoms that make up maybe a molecule, which often is referred to as primary bond, but specifically called interatomic bonding. Interatomic bonding. The word interatomic simply means that the bond or the force of attraction is occurring between two or more atoms in one molecule. In one molecule. We also have a second type of bonds called intermolecular. The interatomic bond, which sometimes is referred to as primary bond, may occur between only one mole or one molecule of a substance. The intermolecular, look at the words, let me explain. This is interatomic. It means that between one atom and another atom, then there's a bond here. Okay? The intermolecular means that you are going to talk about a molecule, so that if you have this and that as a molecule, then we have another one there. There could be another bond between them. So the bond between this one molecule and that one molecule is what we call the intermolecular bond. Whereas the first bond between this atom and that atom is called the interatomic bond. So the first one is between atoms in a molecule, and the second one, which is the intermolecular bond, is between a number of molecules, which is sometimes referred to as secondary bond. We have three major types of the primary bonds or the interatomic bonds, and we have about 4 types of the secondary bonds. before I go to explain that, I want to come to the table and illustrate the types of bonds that I've mentioned. Now, let's take this thing that I'm holding as an illustration. This molecule here is a magnified water molecule. In chemistry, very soon you will grow in chemistry, and I'll explain to you that this structure that I'm holding here represents water molecule, where the red ball here represents the oxygen, and then these two white balls represent my hydrogen atoms. They are bonded like this. So oxygen is bonded to hydrogen here, and this oxygen is also bonded to another hydrogen here. Remember that the formula for water is H2O. Okay, 2 hydrogen atoms and then 1 oxygen atom. 2 hydrogen atoms which are represented by the white balls, and 1 oxygen atom represented by the red ball. Now, why are they not maybe horizontal? Why is the bond here not horizontal but in an angular shape? That you will know when you grow. But that is the shape of a water molecule. It is not straight, it is not horizontal, it is bent at an angle. We'll explain it when we grow in bonding. Okay? Now, so if you have water molecules, if I take this water here, there is water in here. Or I take water that I'm pouring here. You see it running through. You see it running through straight into the beaker. We are not seeing the water molecules as I showed to you in the water. We are not seeing them. Okay? But this water here and then that water molecule here suggests that we have several millions or trillions of these water molecules in there. So it is just one molecule that when you pick and magnify, you see the shape to be like this. So like in this container, I have water in there and I have put in the molecules of the water in it. What I'm trying to illustrate here is that in the water molecules here, that is the volume of water, within it we have several of this in there. And how are they bonded? If you use a magnifier to magnify any volume of water, that is how we are going to see the molecules or the particles of the water molecules arranged. You see them as hydrogen bonded to oxygen and then another hydrogen. Okay, and then here this could also be bonded to oxygen and then hydrogen, and then it will continue oxygen, hydrogen. So they come together for us to be able to see the water as we see it in the beaker, all continuing. Now, why is it that I'm joining these atoms with different types of lines? The different types of lines, it's telling me that this is a primary bond, an interatomic oxygen hydrogen, forming 1 mole or 1 molecule of the water. But because when I begin to pour the water, they don't come out one by one like a drop, and then another drop will come. It is telling me that the volume of the water is also, the molecules within the total volume of the water are also bonded together. And so it means that this mole of water, or this 1 mole or 1 molecule of water, is bonded to this 1 mole by the dotted lines. So in short, I'm separating the interatomic bonds from the intermolecular bonds with the straight line and then the dotted line. They are both representing bonds. And in this illustration, the dotted line is representing my intermolecular bond. A bond between 1 molecule of water, another molecule of water, and another molecule of water. But within that molecule of water, the atoms are also bonded together. So these are the two major types of bonds we have. Interatomic, which some people also call intramolecular. If you say this one, if you say intra, it means within. If I say intramolecular, that is within one molecule. The bonds there is the same as intramolecular, is the same as interatomic. And that's the first type of bond to form one molecule. Before the molecules can also be bonded to each other to form the entire substance that we are referring to. Here I'm using water as the substance. Within the water substance, we have water molecules. Simply put, the attraction between members of a family, and then the attraction between a family and another family. Okay? And what do you think the strength of these bonds would be? The bond between a sister and a brother and a mother compared to the bond between one family and another family. Simply put, interatomic bonds are mostly stronger than intermolecular bonds, because several reasons will account for that. We'll be doing all this in series in our next videos, and we see why some bonds, the primary bonds, are stronger. Of course, you also have some secondary bonds that are also very strong, because in some compounds or in some substances, the primary, you don't see a distinction between the primary and the secondary bond. They are the same type of bond, so they are equal. They become equal. But you hardly will get a secondary bond being very stronger or being stronger than a primary bond. So that is the basic illustration of what you mean chemical bonding. Two main types, interatomic or intramolecular, that is within one molecule, the forces of attraction that hold the atom together, called a primary bond. Other name is intramolecular bond, the main name being interatomic bond. Then we have a second type of bond that holds the molecules of that substance together. That is intermolecular. The inter means between what? Between molecules. Molecules. Okay? And then the interatomic means that between atoms. So this is a secondary bond, and that is primary bonding. Now, let me go back and list the types of so under one, the types of bonds, primary bond that we have. One, we have A, we have ionic bonds. B, we have metallic bonds or bond. Then we have C, covalent bonds. Under this, we may have some types of covalent bonds, but when we get there, we explain them. They are all covalent, but the way they are formed gives them an additional adjective. Okay, so we may have something called dative covalent bond, we may have something called nonpolar covalent bond, we may have something called polar covalent bonds. They are all covalent in essence, but the way they are formed gives them different names. So we have ionic bond, metallic bond, covalent bond. These are the three main types of primary bonds or interatomic bonds. If you come to two, that is, if you come to secondary bonds, that is the intermolecular bonds. Of course, we have, again, some being ionic. The ionic, we can also call it, the other name for ionic is electrovalent. Let me mention that, it's either ionic or electrovalent bonds. So when you come to the intermolecular, some of them are also ionic or electrostatic. Or electrovalent bond. And then that is A here, B. Under the let's say we also have covalent. We have covalent bonds. We may also have covalent bond being intermolecular. And then we have C, hydrogen bond. As an intermolecular bond. And then we can also have a D, we call it van der Waals. So, these are the three types of interatomic bonds or primary bonds. When it comes to intermolecular bonds or forces, we still have ionic or electrostatic there, we still have covalent there, and then we have hydrogen bonds, and we have van der Waals forces. Now, the very basis of life, as I've already mentioned, or the explanation to why substances exist the way they are. I'm coming back to the table to explain. What do you see here? I guess you know it. It is copper metal. This substance, this aluminum metal. Why is it that this aluminum metal is softer than the copper metal? This is sodium chloride, the ordinary salt. Why is it not as hard as the metals that I've illustrated first? This is the ordinary soil, earth, soil. Why are they always in particles? If I begin to pour it here, you see that they pour in particles. Why is it so? I've already illustrated the water. This is a molecule representing something called methane. Okay, this is the shape of methane, where we have carbon bonded to hydrogen, 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 and hydrogen. In methane, the formula is CH4, or we could also say tetrachloromethane, where carbon is here and is bonded to hydrogen, 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 or it is bonded to chlorine, 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 chlorine. That is the shape of it, all these. That could also represent another molecule. And of course, we have also our water here. Why do they all exist in different states? The metals are kind of solid. The sodium chloride is also solid. The soil is solid. The water is a liquid. And unfortunately, because gases are not stable, I'm not able to illustrate a gas here. But let me say that assuming I put oxygen gas there, or I put nitrogen gas, which I cannot see with my naked eye, but I know I'm breathing in the oxygen. As I stand here and I'm teaching, I'm breathing in. You are also breathing in as you sit there. What are you breathing in? You are breathing in oxygen. Or there is air blowing around you. What is the make of that air? That air contains oxygen gas, it contains nitrogen gas, it contains some carbon dioxide gas or carbon monoxide gas, various types of gases. Okay? And then, of course, in your kitchen, you have the butane, propane, condensed in a cylinder as you call it gas for your cooking. They are all substances. Why do they exist in the form of that gas? Why is it that this exists as a solid? And then sodium chloride also exists as solid. We have already said that attraction, force of attraction, is the basis of life. And so depending on the strength of the attraction that exists between the molecules of that substance, the substance may either be a solid, may be a liquid, or a gas. The force of attraction determines the state of any substance. If the force of attraction, that is the intermolecular or that is the interatomic or the intermolecular, if that force of attraction, which in chemistry we call bond, is high, then of course you exist as a solid, a hard solid. If it is weak, somehow you may exist as liquid, and it is very weak, you exist as what? Gas. And some of the gases are so, some of the force of attraction are so low that the gases sometimes are difficult to even exist unless mostly you condense them, bring them together closely. Else, they will dissipate into the atmosphere. Because the force of attraction holding one molecule to the other is so weak that as soon as you leave them, they break apart and each molecule will go its way. And if each molecule goes its way, then of course you cannot have that substance existing. So that is basically what we mean by chemical bonding. In our next video, which I expect that you come with me and watch, because this is only an introduction, we are going to take the bonding or the types of bonds one by one and explain them. Thank you for coming along. I want you to understand nature. Science is all about trying to understand nature so that we'll make use of what God has created for us to advantage. And that is what we are helping you to study.